Hey guys, welcome to Unit 3. Unit 3 is often the most challenging unit for students. It's about graphing. If you don't feel comfortable with graphing, that's okay. We're going to start with plotting ordered pairs, finding a solution, seeing how an ordered pair, an xy value, is related to an equation, how an equation is related to a line on a graph. And we'll get to know desmos.com and how to use it to check answers, to find answers, and to get you more comfortable with graphing and the coordinate system. So if you have questions, reach out, don't give up. You'll get it, and this will help you do future algebra. So for 3.1, we're going to plot pairs, determine whether an ordered pair, by ordered pair we just mean open parentheses, a number, a comma, another number, and then the close parentheses. The first number is related to the x-axis of a graph, and the second number is related to the y-axis of a graph. We will decide whether a given ordered pair is a solution to a given equation. We're going to graph linear equations. If you'll notice the word line in linear equations means when you put an equation into a graphing calculator, or when you start graphing that equation, you get a straight line of some kind in some direction. Nonlinear equations, on the other hand, will not be straight. They might be like this. They might be like this. I was trying to go for this. And basically, you're taking x and you're doing something to x. This one would be you're cubing x. And you get a line that is not straight. So linear means it's a straight line and your x value is not raised to any power. Nonlinear equations, your x value might be raised to a power. Your graph is not going to be straight. You'll see other nonlinear equations. I won't just draw them all right now. So to understand that, we first need to understand the rectangular coordinate system, or the plane, or just the graph, right? So what you have as your graph is you have a number line, right? The middle of the number line is 0. And then in this direction, you have positive numbers. In this direction, you have negative numbers. That's a number line, right? An important thing to know about a number line is it goes forever in two directions. If not, it's called a line segment. So this number line, if we were to make it intersect with another number line, we would have a coordinate system. In that coordinate system, you can now map a point onto two dimensions, right? This dimension going left and right, and this dimension going up and down. This is your x-axis, and this is your y-axis. But you can just think of it as two number lines that intersect each other. Where do they intersect each other? They intersect each other at 0. So the coordinate point, or the ordered pair for the middle, is 0, 0. Good. So ordered pairs are two numbers associated with a point on a graph. The first number is the horizontal location. Horizontal means like this, like horizon. Location of the point. The second gives the vertical or up and down location of the point. Good. So the coordinate is a number in the ordered pair, your x coordinate or your y coordinate. Okay. When you have the point, if you have the ordered pair 2, -5, your x coordinate is the 2, is the first number always. Your y coordinate is your second number. Good. Your x-axis is this number line. Your y-axis is this number line. Your origin is where they cross each other, and it is 0, 0. And then the quadrants are the 4 regions created by the intersection of the two axes. We don't really talk about quadrants much after this first lesson, but they are quadrant 1, and then we go counterclockwise. So this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay? It's more important that you understand the x-axis, the y-axis, and the origin, and how to read an ordered pair than that you understand the quadrants. We don't reference quadrants a ton. Good. But the two axes cross, and in that crossing, we get 4 pieces of the coordinate plane or the coordinate system. To graph an ordered pair, you want to start at the origin and then move a number of units to the left for negative or to the right for positive, and then move up or down depending on if your second term is positive or negative. Okay, so start at the origin will be 0, 0, right? Move x units to the left if it's negative. So if we had as our x value was -2, we would move 2 units to the left. Or if it's positive, we could move 3 units to the right. So we move to the right if that number is positive, we move to the left if that number is negative. And then for the y value, totally separate right next to it, right? Move up if it's positive, or move down if it's negative, okay? So from the origin, -2, 5 would be -2, so 2 units this way, 5 units up. Whereas 3, -4 would be 3 units this way from the origin, or from 0, 0, 4 units down. Okay? So, when we are graphing an ordered pair, let's just pick some points, okay? If I had the point, let's do -2, 5, 3, -4, 0, 2, and -4, 0, okay? Each of these, the first number is your x value, the second number is your y value. The first is your x, second is your y. Where are these on the quadrant plane? 1, 2, 3, 4 counterclockwise, starting in the upper right-hand corner. And from the origin, for -2, 5, I'm going to move -2 on the x-axis, +5 on the y-axis. Those two meet right here, so that's -2, 5. That would be in quadrant 2. Good. 3 would be a +3 on the x, -4 would be a negative or down 4 on the y, 3, -4, that would be in quadrant 4. 0, 2 is interesting because 0 on the x-axis means I'm not going to go left or right, but I'm going to go up 2 on the y-axis. So that is it's not in any quadrant, we say it's on the y-axis. Okay, and then -4, 0 means I'm going to go over 4 in the negative direction. And that's on our x-axis. And that is how you would graph an ordered pair. You have your horizontal number line, your x-axis, your vertical number line, your y-axis, and then you have all of these. The whole thing is just called your plane, okay? So this is all a plane. This first number in your pair relates to your x-axis. And the second number in your ordered pair relates to your y-axis. Good? These are your number lines. Your x-axis and your y-axis are the number lines. Okay, so let's plot the point 4, 2. All you're going to do is start at 0, 0, go over 4, up 2. You can call it 4, 2, or you can just call it A. 2, negative 3, we're going to go over 2, down 3. Call that C. Sorry, I went out of order. Negative 3, negative 2, negative 3, down 2. That'll be B. 0, 4. 0 on my x-axis, but up 4 on my y-axis. That'll be D. And then 5 means I go out 5 on my x-axis, but I don't move on my y-axis, and that'll be E. Good? All right. Now, how to determine whether a point is a solution. So what is the relationship? I now understand this. Okay, I got it. You can put points on here. The point is an x and a y value, right? That x and y value tells me where it is. So if I go negative 3, negative 2, I will find myself at B. So it's where it is, it's the direction to find it, it's its name, right? But what does that have to do with an equation? So for an equation, you will have an x value and you will have a y value, and for a coordinate point, you have an x value and a y value. The first term is your x value, the second term is your y value. That means for 3, negative 2, x is 3, y is negative 2, right? When we are graphing, so when I draw this, or when I draw this, what I'm actually doing on the coordinate plane is connecting points into a line, and each point is its own location. Each point has an x value and a y value, but there are infinitely many points, right? When you're looking at the graph, I'm just going to go to Desmos now. When you're looking at a graph of y equals x, and this again is just desmos.com/calculator. If you go to desmos.com, the first button on there will be graphing calculator. So just press that button, type whatever you want into here. You can put y equals x, or you can put the points 1, 1. Okay. When I graph y equals x, it gives me a graph of from negative 10 to positive 10 on x and from negative 10 to positive 10 on y. But I can zoom in and I can get as small as I want, and it'll never run out of, right, numbers. There are infinitely small number of numbers on this number line. It's just how small does your graph go, okay? So it's a series of points, but there are infinitely many points because you can also zoom out and get really big and get big numbers like infinity and negative infinity, right? Because each individual point has an x value and a y value, we can write an equation for anything that we can graph. Let's look at it again. So, oops, that was zoomed out. Let me zoom out. So I said I graph the point y equals x or x equals y, and I graph the point 1, 1. That's on the graph. I can also kind of try to follow the graph and see that 1.51 and 1.51 is also on the graph. 2, 2 is on the graph. 2, 1 would not be on the graph. So that line is all of the right answers to the question y equals x. When y is 1, x is 1. When y is 1, x isn't 2, right? So if we have the point 3, negative 2, I'm going to graph it, and we have the equation 2x plus 5y equals negative 4. Let's graph both of those things. So we said it was x equals 3, y equals negative 2. So I'm just going to put that in as a point. 3, negative 2, where would that be? First quadrant, second quadrant, third quadrant, or fourth quadrant? It's in the fourth quadrant. And then I'm going to write the equation they gave us. The equation was 2x plus 5y, 2x plus 5y is negative 4. And once I give it a number here, it's going to appear on the graph. And you're going to see that that line of that graph goes right through the point 3, -2. Why is that? Because if I put in, right, think about it. Pause the video and think about it. If I put in 3 for x and -2 for y, what will happen? 2 times x plus 5 times y is equal to -4. If I say x is 3 and y is -2, it makes this true. 2 times 3 is 6. 5 times -2 is -10. 6 minus 10 is -4. If I chose the point 10, 1, is that going to be a solution of 2x plus 5y equals -4? 2 times 10 plus 5 times 1 equals -4. What do you think? 2 times 10 is 20. 5 times 1 is 5. Does 25 equal -4? It does not. And if I go over to Desmos and say that my point is 10, 1, that point is not going to be on the graph. So that's what we mean by, is it a solution? If I graph this line, will the line cross the point 3, -2? Okay? So is -1, 6 a solution of 3x minus 4y equals 5? You're welcome to put -1, 6 into Desmos and put 3x minus y equals 5 into Desmos. That's a perfectly reasonable way to answer this question. Good? -1, 6 and 3x minus y equals 5? No, it is not. Or you can say 3, -1 is my x, 6 is my y. 3 times -1 minus 6 is 5. 3 times -1 is -3 minus 6 is 5. -3 minus 6 is a -9 equals 5. Not true. Okay? That is what they mean. A linear equation in two variables is an equation that can be written in the form ax plus by equals c, or y equals mx plus b. It could be written in a variety of ways, but it has a y and it has an x, where a, b, and c are real numbers and a and b are not both 0. If they're both 0, then you just have one number, which doesn't really, you can't really graph a number. You would need a pair, like a point, or you would need either an x value or a y value or both. Okay? All right, how do we graph? To graph an equation, you want to solve the equation for y and it choose 3 values for x. For the values for x, I like 0 because it's easy, right? And then -1 and +1, just to see how the graph will behave on either side of my x-axis, right? So if I think about my x-axis, here's x equals 0, here's x as 1, here's x as -1. So if I plot 0, 1, and -1, I'll be able to see what it's doing on both sides of that origin. Good? Okay. So if we wanted to graph the linear equation y equals 3/4 x plus 3, I strongly encourage you to just use Desmos. So we said it was y equals 3/4 x plus 3. Notice though that when I graph this, and if I said that the x was down here, I get a totally different graph, okay? So make sure your graph looks exactly like how it's typed in MyMathLab. Good? So you can graph it like that, or you can graph it by hand. When we're graphing it by hand, you want to make a table like this one. So we'll have a table of what is, not good. What is my x? And then what does that make my x, y? Okay, so I said I liked -1, 1, and -1, 0, and 1. So when x is -1, and if you don't like -1 because you don't like fractions, you can say I want x to be 4, and then 3 times 4 divided by 4 just leaves me with 3, right? So instead of -1, we can say it's -4. Now I have y equals 3/4 times -4 plus 3, right? 3 times -4 divided by 4, -12/4 plus 3, -12 divided by 4, -3, right? Plus 3 is 0. So when x is -4, my point is -4, 0. We okay? You can use -1, it just looks harder because of the fraction. If you use a number that is a factor of 4, it'll be easier. Or not a factor of 4, a multiple of 4. All right, let's use 0 though. When x is 0, y equals 3/4 times 0 plus 3, right? Anything, even if it's a fraction, times 0 is 0. So we just have y equals 0 plus 3, which is 3. So that's the point 0, 3. And then finally, since we did -4, maybe a +4, right? Because I said I like -1 and +1 up here, but I want to account for that 4. So now I'm going to say y equals 3 divided by 4 times 4 minus plus 3, sorry, blocked by my own hand. Good. 3 times 4 is 12 divided by 4. 12 divided by 4 is 3. So 3 plus 3 is 6. Good. So when x is +4, y is 6. And it is helpful if you easily see a pattern, right? For every x that I move up 4, so I add 4 to x, I add 3 to y. Is that still true? If I add 4 to x, I should still add 3 to y. You start to see a pattern. You can even check your pattern to say, what if I said that x is 8, right? Then it's y equals 3 divided by 4 times 8 plus 3. 8 times 3 is 24. 24 divided by 4 plus 3 becomes 6. What, right? And what? 6 plus 3 is 9. So 8 is 8, 9. So I went up another 4, up another 3. I added 4, added 3. So from -4, 0, add 4, add 3, add 4, add 3, add 4, add 3. So I can see a pattern. And if I graph those points, like -4, 0, I'll see them on my graph. All of the points that I find in my work, I will be able to see on my graph. Okay? Example 5. Graph the linear equation 2x minus y equals -4. Good? You can solve for y or not if you don't want to. You can also just start putting it in, right? 2 times 0 minus y equals -4. That might be a little difficult. So I'll solve for y. So I'll subtract 2x, -y equals -4 minus 2x. You're also welcome to move the y so that it's positive, or divide by -1. Right? Negative divided by negative makes a positive y. -4 divided by -1 is a +4. -2 divided by -1 is a +2. So y equals 4 plus 2x. And again, I'm going to make a table. So when my x is 0, y equals 4 plus 2 times 0, y equals 4, right? When my x is 1, ooh, -1, sorry, I like the negatives up there. Y equals 4 plus 2 times -1, y equals 4 minus 2, which is 2. So we should see a difference of I add 1, add 2, right? So this one should be +1, should be 1, 6. But let's see if that's true. Y equals 4 plus 2 times 1. Y equals 4 plus 2, which is 6. Good, so you can see your pattern. And if you were to graph it by hand on your XY axis, need to restart. So my y's are all positive, 2, 4, and 6. So I'm going to make my x-axis down here, y-axis tall. So between an x of -1, 0, and 1, that's 1. Sorry, I'm saying 0, and I can't not write what I'm saying. 1, 2, 3, 4, 5, 6. -1 is at +2. 0 is at 4. +1 is at 6. So you can see the line coming down. So make sure you know how to plot the points. And you know how to find the points. Sound good? All right, the intercepts are the points where the graph crosses the x-axis or the y-axis. To find the x-intercepts of your graph, let y equal 0 and solve for x. Then the intercept is whatever you got for x, followed by the number 0. To find the y-intercept, let x equal 0 and then find for y. The y-intercept is 0 and then whatever number you found for y. For example, here is our x-intercept, 0, 4, right? Because x is 0, y is 4. So that's, oh, sorry, that's our y-intercept. That is confusing. So if we graph 2x equals y by finding and plotting only the intercepts, that means that to find the x-intercept, what does it say? To find the x-intercept, y is equal to 0. Oh, sorry. Oh. Y is equal to 0. To find your y-intercept, x is equal to 0. Two x equals y. Y is equal to 0 for my x-intercept. 2 times x equals 0. That's all we're doing, okay? Now solve for x. X is being multiplied by 2. So to undo being multiplied by 2, I'm going to divide by 2. 0 divided by 2 is just 0. X is 0. So that means my x-intercept is 0, 0. For my y-intercept, might be the same. I have 2x plus y, or sorry, 2x equals y. And I'm going to make x 0. So that's 2 times 0 equals y. 2 times 0 is 0. 0 is y. So my y-intercept is 0, 0. Let's do another one. Graph 5x. Let me think of something good. Minus 10 is y. Okay, so if I wanted to find my x-intercept, y has to equal 0. So for my x-intercept, it's going to be 5x minus 10 is 0. Good. Then we're just going to solve for x. So I'm going to add 10, and I'm going to get 5x is equal 10, divide by 5, divide by 5, and I get x is 2. So that point is going to be 2, 0. That's my x-intercept. For my y-intercept, now x is 0. So 5 times 0 minus 10 is y. 0 minus 10, negative 10 is y. So that point is going to be 0, negative 10. You see the difference? So my y-intercept is, oh my gosh. My y-intercept has a 0 in the x position. My x-intercept has a 0 in the y position, and I'm going to throw these across the room. All right, graph y equals x squared. I strongly encourage you to throw this into Desmos, okay? Y equals x, shift number 6, 2. When you see it, it looks like that. What if x is 0? If x is 0, y is 0. If x is 2, y is 4. If x is negative 2, oh, harder to tell. If x is negative 2, y is 4. Good? It shows you what we're doing. Desmos shows you what you're doing. Desmos is available in all the exams. Okay? So, if I had to graph y equals x squared by hand, I'm going to pick easy numbers, right? So if x is 0, we already saw it, right? Y equals 0 squared. What is 0 squared? 0. If x is negative 1, y equals negative 1 squared. What's negative 1 times negative 1? Y equals 1. So that point is negative 1, 1. What if x is a positive 1? Again, I like to do the easy numbers. There's nothing wrong with it. Y equals 1 squared, which is just 1. When you look on Desmos, it's the same. So we have 0, 0, we have 1, 1, and we have negative 1, 1. What about, let's do negative 2, right? So then we have y equals negative 2 squared, which is 4. So for negative 2, we have 4. Positive 2, it's going to look the same, right? Y equals positive 2 squared, which is 4. Matching. So that is the graph of y equals x squared. Example 8 asks us to graph the absolute value equation. Y equals the absolute value of x. Again, fastest way to do that. Y equals, come down here to show keypad. Look at it. It's right there with an A in between it. Absolute value of x. Done. Good. At x is 0, y is 0. At x is 5, y is 5, right? You can kind of tell that they are matching each other. At x is negative 5, y is again a positive 5. Helps you understand what the equation is doing. So when x is negative 5, what is y doing, right? Y equals the absolute value of negative 5. So that is positive 5. Right? When x is at negative 2, y equals the absolute value of negative 2, which is a positive 2. When x is 0, what's the absolute value of 0? It's the distance from 0 to 0. It's 0. When x is a positive 1, y is the absolute value of 1, which is 1. So you can see that it's kind of making a pattern. If x is a positive 5, y is going to be a positive 5. So that graph looks like this. It never goes below the x-axis because you're not, it never goes below the x-axis because you're not going to get a y value that is negative. There's no number that you take the absolute value of and you get a negative. Our last example is y is the square root of x. This one's harder to just picture in your head because we're taking the square root of a number, right? Squaring a number makes it grow really, really fast. So for every x, we leap up in y, right? But the square root is actually going to make a shape more like this because for an x of -1. So if I say y equals the square root of -1, what happens? What is the square root of -1? It's a not real answer. So there is not going to be any number on the left side of the y-axis. X cannot be negative. There's no graph or no solution. When x is 0, y equals the square root of 0. What's the square root of 0? The square root of 0 is 0. So our graph will start at 0, 0, and then 1. What is the square root of 1? The square root of 1 is 1. Sorry, we're talking about the xy value, the coordinate point. So that's going to cross there. But what's the square root of 2? X is going to be 2. Y is going to be the square root of 2. It's not a perfect square. It's a decimal number. The square root of 2 is 1.41, right? What about if it were a perfect square? What if it were 4? So when x is 4, way out here, y is going to be 2. Because the square root of 4 is 2. When x is all the way out at 25, y is going to be 5, right? Because the square root of 25 is 5. Y is the square root of x, so 5 is the square root of 25. So it's just going to slowly move that way, all right? And those are just things that you should picture. So when they say the graph of y equals square root of x, I want you to think of that. When they say y equals absolute value of x, I want you to think of that one. And when they say y equals x squared, I want you to think of that one. When they say y equals x, I want you to just think of that. That is y equals x. It's just a straight line going through every value, right? It's going through 1, 1, it's going through 2, 2, it's going through 10, 10. Y equals -x just goes the other direction. So get to know what these graphs look like if you feel intimidated by them. They're nothing to be intimidated by. And thank you so much. Have a good day.